Hello, this is Gwen Hoheisel with WSU Extension. I have been working in application technology for almost 15 years and find it really fascinating. When applications are done well, it's a key component of an IPM program. But when they're done poorly, it leads to loss of fruit and drift. And so today I'm going to talk you through two areas of sprayer manipulations that I think are critical. But in order for you to adopt any of these items discussed here, it really starts with the business plan of who at the farm is going to integrate and monitor these practices. This is really critical for success of calibration and optimization of sprayers. So let's start first with air. If you get your air volume and direction correct, it will drastically improve your coverage. So in any air-assisted sprayer, really, it has the function of using the air from the machine to push droplets into the canopy. Therefore, it's easy to think of it this way. Wherever air goes, droplets follow. If your air pushes through the canopy, then the droplets will blow right through also. So we want to match the air volume to the size of the canopy and keep the spray in a single canopy row. Air direction is also critical and one that manufacturers have been solving for decades, hence the reason for tower sprayers. We want the air and the droplets to be pushed directly into the canopy. So let's take a closer look. This is a diagram from a study that we did in blueberries. It shows two different sprayers, but it's really illustrative of the effects of air. What I'm displaying here is actually air speed, and while it's not the same as air volume, it is an easy thing for growers to measure with a simple handheld anemometer. This sprayer at the top right is an electrostatic sprayer with comparatively less air volume than the other. When you drive it up the row, the side closest to the sprayer showed 3 mile per hour airspeed. The mid canopy was 1 mile per hour, and 0.5 miles per hour on the far side of the canopy. What this would indicate is that very likely many of the droplets stayed in the canopy as the airspeed dropped. To measure this, we measured infield drift on the ground in the middle of the rows, seen as black rectangles. The numbers below show a range of 40 to 150-ish nanograms per centimeter squares of deposition. Really, the exact number is not the point, but rather look at how a sprayer with more air pushes more deposition past the intended canopy. So the Cannon sprayer on the bottom was designed to have large air volume and speed primarily to match the needs of the farming practices in horticulture. It can be driven around the perimeter of a block to spray 3 to 10 rows at any one pass. This is important if you have rows planted too narrowly or other needs that don't allow you to enter the block. This isn't necessarily a poor sprayer. It is in fact doing a great job of what it was designed for. But you can see as it drives up the row, the air speed is 6 miles per hour in the first row, 21 miles per hour in the second row, and 4 miles per hour in the third row. The deposition on the ground in the mid-row past the intended spray rows is significantly higher than the other sprayer. So again, wherever air goes, droplets go. We need to get this air volume and direction correct. So for growers, how can you tell if the spray is going into the canopy? Well, you can use water-sensitive paper. I'm hoping that one of the key messages you take from this is to buy and use water-sensitive paper to see what's happening in your blocks. Water-sensitive paper is yellow, and when wet, it turns blue. So in this picture, it was from a field demonstration where we hung these cards in the canopy and operated a quantum mist tower sprayer at the same rate, but with different fan speeds. You can see that there is really good and even coverage in the cards with the high fan. The cards with the low fan show all blue cards at the bottom, which would mean that there was likely some runoff from the leaves. Less coverage was in the middle. So which would you choose? Well, obviously, if it was my block, I would probably choose the high speed. But based on the last slides, you should know that this isn't telling you the entire story. You should put water-sensitive paper in the mid-row on the ground, 1 or 2 rows from the intended spray. Then you will see if there's more deposition on the ground with the high or low fan. We obviously don't grow fruit in the mid-rows, so any spray there is simply a waste of money and product. If you were to see less drift with the low fan, then you should choose that setting and adjust the nozzle output so that less is coming from the lower nozzles and more is coming from the mid-range nozzles, and the top looks fairly decent. Direction. Direction is also critically important. If you have a tower sprayer, the direction of the air is pointing directly into the canopy. If you have an axial fan sprayer, you need to make sure that the only nozzles on are those that are pointed into the canopy. This is easy to visualize. Park the sprayer in the mid-row, tie flagging around the nozzle bodies, step back and see which ribbons are aimed into the canopy. Keep those nozzles on. Really, only the top 1 to 3 nozzles and bottom 1 to 3 nozzles are usually debated, except in very large canopies or those canopies that go really over the mid-row. In this picture, if those very top nozzles were kept on, then the spray would go above the canopy, and what goes up does not really come down in the intended places. So again, you are wasting money and risking fruit. Okay, now you know the importance of air. Decide now who will optimize your sprayers and look for proper air volume. Mismatched air is the primary culprit for drift and poor coverage. In this next set of slides, you will see more specific ways on how to adjust air. So, the next big item for us to cover is also rate. Rate really has 2 key components to talk about right now. How much spray should go on that canopy, and how do you calibrate the sprayer so that you know that amount is coming out. When you pick a rate, you can pick a standard rate. In Washington, we do a lot of 100, 200 gallons per acre spraying. Maybe this exact number changes if you have a different canopy, but often we simply pick a number and double it, 100, 200. There is the beauty and simplicity to that. Another way some people look at it is to use tree row volume, which is the concept that you apply a specific amount of spray per area of canopy. This makes sense intuitively when you think that in a low-density orchard, the label rate on U.S. labels is the same, for example, 4 quarts per acre, as it is for a high-density block with twice as many trees. This is the conundrum of U.S. chemical labels. In Europe, they are adopting more of a spray for canopy area as opposed to land area. Nonetheless, far fewer orchards spray in a tree row volume fashion. Lastly, if you wanted to calculate what might be an optimal spray rate, there is a Decision Aid app that was released several years ago that may help you. Again, in this picture, deciding on a rate is not a trivial matter. Horticulture has changed over time. These estimates of 200, 300 to 50, 80 on a tiny canopy may be correct or could be totally wrong. Using tree row volume may also give you a good estimate of rate, but in the mathematical calculations, there is an estimate of density that needs to be guessed slightly in order for you to get a correct calculation. The only way for you to double check your estimate is to put out water-sensitive paper and see where the spray is going based on your sprayer design and the horticultural canopy. So this is why this area is fantastic and challenging, and it's the intersection of engineering, horticulture, and pest management. So, speaking of someone who loves challenges, an engineer named Jason Duveau out of Canada keenly understands this complexity and loves sprayers probably even more than I do. He created and validated the efficacy of a decision aid system or an app called Orchard Max. Be aware, it is only tested on orchards, so if you are cross-commodity and try to use it on another crop, there are actually other apps to help you consider what to spray. Dr. Duveau developed this concept of crop-adapted spraying. Determine where your air is going. then adjust your nozzles, and then make sure the rate is correct. You can download the app at sprayers101.com, and that website is also filled with lots of good sprayer application information. So in Orchard Max, if you download it, you have to enter one time the orchard information like tree height, row spacing, etc. Then you can choose the label rate or the optimized rate based on the tree size. It does allow you to select spraying every row or alternate rows, but be cautioned here. It does not assume that you will be relying on a blow-through method where the sprayer is not optimized or working well. There are times that alternate row spraying may be the goal and work really well to keep residuals high in a field. But it isn't just to blow through randomly, putting spray anywhere. And this is critically important to understand. When this type of spraying was more common, we had a different suite of chemistries, not targeted ones, and now we certainly have a different set of regulations. And again, that technique, I can often demonstrate that drift on the ground seen from water-sensitive papers is as good or better than what's in the canopy, which means that spray is wasted. So one of the beautiful things of this app, besides it being fairly easy to use and very helpful, is that Dr. DeVoe and his team published efficacy data on the use of optimized rates in sprayer setup. It is challenging to get season-long data on any sprayer research, but he was able to go into 3 orchards and look at the grower control, meaning their setup and rate, and compare it with the optimized setting from Orchard Max, listed in these graphs as the treatment. Then they scouted for a gobstopping amount of pests and diseases, and you can see that far less apple damage occurred when the sprayer was optimized. So if you are inspired to try Orchard Max, please just make sure that you convince yourself with when you change your sprayer setting. Use water-sensitive paper before and look at your spray coverage, then change it according to Orchard Max, and again, use water-sensitive paper to look at what your spray coverage is. Okay, so let's look at simple calibration, meaning, are you getting the correct amount or rate out of your nozzles? This is really low-hanging fruit to achieve. If you do not have a maintenance checklist with the expected condition of the parts of your sprayer, the frequency to look at it, then this is the first step. So the pump is basically the heart of your sprayer, and the pressure gauge is like your Apple Watch. It's telling you the reading of your heart or your pump. So if it's bad, then the entire calibration is off. If your pressure gauge used to be fluid filled and now it's dry, it needs to be replaced. If it doesn't return to 0, it should be replaced. So rate is affected by the items in blue. So those are nozzle, speed, and pressure. You know that when you go to a block, that if you want a little more deposition, you might drive a little faster or you up your pressure a bit. But you were trained to do that, which is great, as long as you understand the rest of the complexity of the machine. And it's really important to train someone on how to do proper maintenance and calibration of the machine. So pressure gauges and nozzles are inexpensive and easy things to change, and they have a huge impact on the rate of spray, especially if they are wrong or worn. So to pull this all together and all these concepts together, I'm going to go through 6 steps of calibration, and lucky for you, it has optimization blended right in. Because axial fan sprayers are still the most widely used sprayers in fruits and nuts, we focus this publication on the right on axial fan sprayers. You can Google it with the PNW 749 at the top. So in my presentation here, items in yellow are really on calibration, meaning speed, nozzle, pressure, how much is coming out of the sprayer. Items in black are on optimization in air volume and direction. And I have thought a lot about sprayers, and there are many of us in education thinking about sprayers and the most efficient way for you to optimize and calibrate your machine at once. And so these are 6 steps I'm suggesting. So the first item is to check your speed. Do this at least once per year. Work in the orchard and drive the rows as opposed to driving on gravel, because the traction between the surface and the tire can give you as high as a 15% error. To check the speed, you can do this manually with 2 flags and a calculator. Put the flags 88 feet apart. Repeat this for 3 88-foot courses. And yes, you can make them 100 or 500-foot courses or any length you want. But I like 88 because in the math, the 88 on the numerator would cancel out on the denominator. So you only have to punch 60 divided by the seconds traveled in the calculator. And I like easy things. So you have your sprayer half full and the PTO is on. Then you start the stopwatch when your front tire crosses the flag, and you stop when the same point crosses the second flag. Do this for all 3 courses and take the average time. So if you traveled 88 feet in 32 seconds, then 60 divided by 32 is 1.8, or you're driving 1.8 miles per hour. Alternatively, there are apps and tools to avoid this math. So if you download a biking app, that would give you the resolution of 1.8, or have a GPS on the tractor that is independent of your rate controller, you can take the speed from that. So the adoption of rate controllers, I know, is variable, but it's really important to mention it at this step when we're talking about checking speed. There are many different types of rate controllers, and what they do is they measure your speed through a wheel sensor or GPS, and they adjust your rate as the speed changes. This is fantastic, especially when you're going up or down a hill where you can lose or pick up a half a mile an hour. Your rate coming out of your sprayer will be very different with such a difference in speed. Some rate controllers have a simple display, and others will link with software and map your spray rate through the entire orchard. But the important point here is that there is a sensor, and you need to make sure that the sensor is correct. So use one of the methods in the previous slide to once a year calculate your actual speed, and then make sure that the same speed is on the rate controller. So I have seen them to be spot on the rate controller, speed matches, or 1 and sometimes even 4 miles per hour off. So remember that the rate controller uses the displayed speed on the computer. So if it is off, then your spraying is off. So step 2 is one we've already talked about. So again, adjust the direction of the air by visualizing the flagging and where the air is going. Remember to only open the nozzles that have flagging blowing into the canopy. Record this setting for each unique canopy architecture that you have. Not each block, but each unique canopy shape. Do this step early and in full canopy. And if you have a directed tower sprayer, you can change the swath of air by adjusting the heads. Like in this quantum mist tower, the swath or airflow widens if the heads are moved further back from the canopy. On an Accutech tower, if the pneumatic heads are spaced really far apart, it creates a wider swath. Make sure that this still aligns with the canopy. When you find your ideal settings, at the end of this entire calibrations process, mark the fan location and have folks check this with every fill tank. Things get knocked around in an orchard, and you need to make sure that the overall system is still working as intended. Step 3 is also about optimization. Match the air volume to the canopy. Do this by tying a ribbon or flagging on the opposite side of the canopy that you are driving. So here it's faintly seen as blue ribbons on one side and the tractor is on the other side. Drive by and see how the flagging is moving. If it blows straight out, it's too much air. in small canopies in dormant season like this picture, it's really hard not to have too much air. But if the ribbon flutters a bit, then it's perfect. If you have too much air and you have an axial fan sprayer or a multi-headed sprayer, such as like a quantum mist or something with the Sardi head fan with exchangeable nozzles, then you can easily try to gear up and throttle down. So what this means is that you increase your gear, which makes you go faster, but you throttle down. Depending on what type of tractor you own, the display will go from 2400 to 1900 RPM or like 540 to 540E. But when you throttle down, you reduce the speed again, but this also reduces the rotations of the PTO and therefore the rotations of the fan and the volume of the air from the fan. As an added bonus, it saves on fuel. So other options for these sprayers, and you can see that I put gear up, throttle down as a second option for multi-headed fans, is because what's really cool about these new sprayers is that they often have high-low fan setting or fans that range from 1 to 10. This is the easiest way to adjust it. So you'd keep all your tractor settings the same and you take advantage of the mechanization that's improved with the sprayers. So our instinct is generally to turn up the air in full canopy and big open vases, canopies. But I would encourage you to visualize the spray with a high fan, using water-sensitive paper, mind you, and again, using the lower fan speeds. So very often in my demonstrations, the spray stays in the canopy and more deposition is seen in the center of the tree at slightly lower fan speeds. One caveat to all of this is that if you have a pneumatic sprayer, this is a totally different technology that relies on high-speed air to cut through the stream of liquid to create fine droplets. You would never want to do something like gear up, throttle down, or lower the fan speed because you wouldn't get the nice droplets. You would be using the sprayer incorrectly. So lastly, once you get the ideal settings and the optimal settings, don't forget to record the best solution of the gears and RPMs for that canopy shape or architecture block. So step 4 is back to calibration, because you know the nozzles that you want to keep on and the air volume. So now you need to calculate the gallons per minute from each nozzle and select the nozzles that you want. Honestly, you can do this with math using the equation that's listed here. Or instead, use an app like BindTech on your cell phone or TurboMist on your computer. So even now, some consultation companies, Crop Consultant, some of those will give you a nozzle setting, but I have to stress this, that it is only good if you communicate the number of nozzles that you're using and the speed that you're driving, because of course, as you can see in the equation at the top, that miles per hour, row width, and the block, all of that matters as to which of what the rate is coming out and what the best settings that the consultant would give you. And when you're asking for these things, we all sort of know that we put in different nozzles in different nozzle bodies, especially in an axial fan sprayer. Sometimes less true for a tower sprayer on a fruiting wall. So the concept is simple, that the nozzle flow rate at a certain height is proportional to the volume of the canopy at the same height. So the concept is simple. The implementation of it is more challenging. And so we often think of the old 1/3, 2/3 rule shown in this picture, but really figuring this out by hand and then seeing if the coverage is adequate is a lot of math. So it's better to do this on a spreadsheet or one of the pieces of software that I just showed in the last slide. Okay, so the last part of step number 4 is nozzle selection. And there are so many different nozzles, and it can sometimes be confusing to which nozzle to pick, but that really warrants its own talk. But in this, please at least consider the material of the nozzles. Materials are given a resistance ratio that can generally be thought of as how quickly it wears out, and especially with corrosive materials. So, brass has a resistance ratio of 1, while ceramic is 100 to 200 times that. And a few years ago, we did a price comparison of nozzles at many different stores and different materials. You can read the full results in this extension publication. And again, you can search for FS 352E. But essentially, ceramic is not that significantly more expensive, especially if you consider that a brass or stainless steel nozzle can wear, and I often see them as much as 20 to 30% off. So you can think what 20 to 30% more chemical is costing as opposed to the nozzle cost increase. To me, it's worth every penny. So step 5 is checking the nozzles. It's really a choice of management on whether you do it one way or the other. So you can buy commercial devices that work great, and such as the ones shown on the left of the little picture with 4 nozzle adapters. The ones that you can buy commercially from AAMS work great. And I have also found, though, that I have been able to make some basically by going to the farm supply store and buying cow milking nozzles and inserting a narrow tube inside of that. It works well. It is not as accurate as the AAMS, but it's fairly accurate. So you turn the sprayer on, you get water that comes out of it, and then you can measure it into a container or a bucket, or you can use a spot-on flow meter or another brand flow meter. But it works by having 2 metal bars, one at the bottom, one at the top. When the water goes through, it measures the amount of time, and in the little display, it tells you the gallons per minute. It's super fast, it's super easy, and it's a tool well worth investing in. You can hook up the nozzles and measure output like this, and that's totally fine. If any of the nozzles are off, then you need to replace them. Alternatively, you can relieve yourself of this step and simply make a management decision that at the beginning of the season, you will replace the nozzles with ceramic material nozzles that you know will be good. This is a management style. You can check them all or replace them. If you replace them with brass or stainless steel, especially in a tree fruit pesticide program, you should not expect those to last an entire season. You can check them again in the middle of the season if that's something you have time for, or just automatically replace them again. Lastly, step 6 is the seeing is believing step. It is really important to verify coverage if you haven't gotten that from me yet. I want to show you an example of why. So we have a patinator that has slats, and it's this tall white machine. And when you spray into it, it collects water that travels down into the tubes shown at the bottom. And so on the right side of the tubes is the bottom of the patinator, which is also analogous to the bottom of the tree. And then on the other side is the top, or the top of the tree. So we thought we had these 2 great tower sprayers working really well and set for a fruiting wall, but we put them and tested them on the patinator, but it was obviously very wrong, because a fruiting wall, you would want even coverage. What we see is this red line having a lot at the bottom and then curving down to not very much, and then a lot again for at least the multi-head fan sprayer, and then the one on the right, it curves up and down. There are no trees grown in this shape of canopy. Really, what we needed to do was adjust these fans either vertically up and down or horizontally away from the canopy. And on some of these, you can pop them out and make the nozzles even further away from the fan head. The point is that just because the machine looks proper, it does not mean that it is properly working until you verify that it is. So you will not have a patinator, but what you can have is water-sensitive paper. And if you really want to make this slick and easy for yourself, pick up some bright red or orange cow tags and a bag of zip ties. Zip tie the cow tags to different areas of the tree, top, middle, bottom, particularly in the center of the tree. Then what you do is you can use double-sided sticky tape to secure the water-sensitive paper to the highly visible cow tag. So it's really quick and easy to have a sprayer run by, check it easily, either several times in a year, or you can adjust the sprayer, have it run by, and run another trip if you've changed anything with it. But you can set yourself up for success at the beginning. So some take-home messages is, of course, to check changes to the sprayer with water-sensitive paper and invest in calibration tools and replacing parts on your sprayer. But lastly, I have to wrap it up with the key point that successful coverage and pest control is only achieved if someone is assigned to manage this, because what we don't monitor, we cannot manage. Thank you very much.